fun.
All right, it's kind of here. It's just it's encoded in this. So did you guys talk a lot about correction factors in this class?
I don't know, to be honest.
Okay, that's fine. Okay, the the formula for z is x bar minus mu over sigma divided by the square root of n. Okay, that's kind of your general formula for that. In when it's a proportion though, there's an adjustment here down here at the bottom that they're trying to show you.
Okay.
And it looks like you have to use that for this problem, although I'm not 100% sure. The way I know that is they give you a population of 687.
Okay.
Okay, that's big N. Little n is they sample 109. Okay, so if you're looking down there at that formula down there, you need big N and little n. You also need a P. Your P is X divided by little n. X in this problem is 41. They're saying 41 have at least the one tattoo. Okay, so now let's get back to what you are going to do in this problem. I can't believe they don't give you this what you want, but that's okay. So your z-score in your problem is going to be your P. So your P minus the given P. So in this case, it's 0.31. That's from right here. And we've got to calculate this sigma P to go in the bottom. Okay, so this one's fairly involved. So we just have to do some of these calculations here for that. So let's do this in pieces here. So the sigma P is the square root of 687 minus 109 over 687 minus 1 times the square root of P. So that doesn't work out nicely. 41 out of 109 isn't really a nice number. So probably good to go out to like 4 decimal places, maybe more depending on how this is done. So 3761 times 1 minus 0.3761 over 109. So all of that has to be done to get your sigma P value. Okay, that's going to go on the bottom here after we put in the P value of 0.3761 here. So I'm going to go to the other screen. I'm going to just do the calculations here real quick. Recommend doing them with me, but there's quite a bit here. So square roots. All right, so the sigma pi that I get here, 0.042589. That's for sigma p.
Did you put them in together?
Yes.
Okay.
Yes. If you need the intermediate results, I can give those as well.
Okay. Well, I put one in the other one, so I am gonna have the right number.
All right. Really hope this works out nicely. Yeah, I mean it's a reasonable number here. So it ends up being that z is minus 0.1552.
Okay. Okay, let me just share my screen.
I think you mentioned the actual exam is really similar to this, so it might be worth like building a little, thing that redoes the calculation for you where you just change the number, each time. But not sure. So okay, here we go. Number 3. All right, share screen. Suppose a random sample of 58 is selected from population with P equals 0.4. Find the standard error when the population is equal to 364. Make sure to use the appropriate formula. So we just did this, which is nice. The
Same equation.
it is just the sigma p part, which you know would be nice to do this one first. So
Okay.
you're supposed to do this when n, little n, which is in your problem is 58, big
Okay.
N is 364. When little n, 58 divided by 364, and we want to get that value, it should be greater than 0.05. So let's look at that here. And that ends up being 0.16, which is greater than 0.05. So that's when you use this correction.
Okay.
So you're putting in
Oh,
big
so
N.
it's greater than 0.05, then you, okay.
Yes. Yes. And I mean, like, I would even imagine there's a type of problem where this doesn't work and you use the other one.
And if it's less than 0.05, then would that just be the answer?
No, if it's less than that, use the next one, the infinite population.
Okay.
The next one on the page there, I guess. I've this comes up only in this class, so I maybe check your notes on that.
Yeah, okay.
Okay, so big N is 364, little n is 58 over 364 minus 1, square root, p is 0.4, 1 minus 0.4, and then little n is 58.
Okay. Did you get 1.225?
Get a different number there. Let me check my calculation. This first piece, if you're doing it separately, first piece is 0.91813.
Oh, I didn't do it separately.
I did it all together. Just if you want to check any of those, this one is 0.06433.
And then you would just add those two. So maybe I do it.
Multiply.
Okay.
But my guess is just a parentheses imbalance somewhere. This first one, you have to put parentheses in the numerator and the denominator, and I think it adds a square root when you do it in the calculator, or there's another one in the calculator. So it's 364 minus 58 slash 364 minus 1, close parentheses, times square root.
You do that after this?
This is the how you would enter it in the calculator.
Oh, you just do, okay, more parentheses.
Yes, and then one more square root, 0.4 parentheses 1 minus 0.4.
So you don't enter it in the calculator how you read it before?
It does work. If you're using a TI-84, you can enter it like this.
Okay, I don't know why it didn't work then. Maybe I just entered it wrong. Okay.
I could have also made a mistake, so don't.
And then you just times those two together?
Yes.
Okay. Okay. Did you get 0.059?
Yes.
Okay. Do you enter it as 0.059?
It says include 0 before the decimal place, so that the instructions are super important with this instructor to do it exactly the way they want.
Okay. Cool. Okay,
So
next one.
whenever you're ready, you can just share the next problem and we'll work it out together. It's not, it's just a dark screen here. Why don't you try resharing your screen again? Just.
Do you see it now?
It's still dark. All right, let me just share mine and see if that tricks it into working here.
Let's see.
All right, yeah, if you want to try sharing your screen again.
Do you see it?
Just a dark screen again.
Let me just send these over to you on email.
Okay, sounds good.
Oh, that was loud.
It's okay.
Okay. Sorry. Okay, there's the first two problems.
Okay.
Going. Well, how far can I get?
All right, here we go. All right, yeah, this is great. Okay. Number 4 here.
Okay.
All right, so we'll keep going here. So a random sample of 94 was collected and provided a sample mean of 18, sample standard deviation of 1.41. The values, that doesn't matter. Calculate the margin of error for a 99% confidence interval. Okay. So let me go back to your equation sheet here. Your margin of error is always given, and there's actually a couple of formulas here they give you. They give you these two. And you might wonder, well, what's the difference between them? The difference here is whether you know the population standard deviation or not, and then that determines whether you're using a Z or a t-test. And there is just a small, difference between them, but it's enough to not get the right answer here. So we're actually using the second one here because it's a sample mean, sample X bar, sample standard deviation, that's S.
So if the problem say standard deviation, we'd use the first one.
If it's like population or it's known to be, or somehow there's words in there that indicate like this is the accepted value.
Okay.
All right. Now the C is 0.99, which means your alpha is 0.01, which means your alpha over 2 is 0.01 divided by 2, or 0.005. This is where you've got to go to the table to get the t value. So it's t of 0.005, degrees of freedom 94 minus 1. And you said you got some tables. I always do this in the calculator, but I can help you navigate that table if you'd like. It probably won't be in there because at some point it stops giving you every single degree of freedom. But let me.
Here, if you, I can pull up the table right now. Would it be in the T table or the?
Yes.
Okay, yeah. Here.
So here's the value, and it's plus or minus, depends on which direction you're looking, but 2.6. So it ends up being 297, but this would be rounded in yours to 2.630.
How did you find that? Because I have the table pulled up. What did you look at?
can you send over the table, or I can pull one up like yours and show you?
Do you want to just? I have it pulled up. Do you want to just share screen?
You can try that. It wasn't working a few minutes ago. Hopefully that's changed.
Oh, here. I just downloaded it here. I just sent it over.
Okay.
You saw that.
When is your exam, by the way?
In 3 days.
Okay.
Oh, just kidding. It's on Friday.
So 2 days.
Wednesday.
Is it on? Is it online like this? Also.
No, it's in person. It's in person.
Ah, dang. Okay.
Yeah.
All right. So yeah, let me snip in this part of the table. It does go to. It actually does.
Yeah, she prints out all the pages.
Okay. All right.
Yeah.
Okay. So the degrees of freedom in your problem, the degrees of freedom is n-1. So it's 94 minus 1, which means you're looking at the 93 row here. Let me highlight that for you. And then your tail, that was the whole business about. So C in your problem is 99. Alpha is 1 minus C. So it's 1 minus 0.99 or 0.01. Alpha divided by 2, that's the area in the upper tail typically, is 0.01 divided by 2, which is 0.005. All of that tells you that you're now in this column there, 2.630.
Okay.
I use the calculator because it's easy to make mistakes on this and it affects all the calculations, but that's how you do it. Degrees of freedom gives you the row, the area in the upper tail, alpha divided by 2. In this case, it's that. Is that okay?
Yep.
Okay, so the margin of error though is just this part on the right. All right, so the margin of error is 2.630 times the standard deviation, which is 1.41, divided by the square root of n, which is 94. So once you get the value, it's really not that hard. It's just put those numbers in the calculator and get the result here. All right.
0.14. Oh, 2 to small. Okay, so 0.15.
I got 0.38. We're somehow off here. 2.63 times 1.41 divided by the square root.
I didn't times it by 2.630. Yeah, now I got 0.38.
Fantastic. All right, so let me grab the next question here. Should start moving through a little faster here through this. Okay, question 5.
Yes.
All right, random sample of 39 was collected, n equals 39. Sample mean 2,290. Population. So this is different. See how this is population standard deviation? That's sigma. That's good. The mean values, okay, we don't care about that. Calculate the margin of error for 98% confidence interval. So I'm going to go back and grab the formulas for this.
Okay.
Because the population standard deviation is given, you are using the top one.
Okay.
All right, now your C is 0.98. Your alpha is 1 minus C, so 1 minus 0.98, 0.02. You want alpha divided by 2, so you take that 0.02 and cut it in half. That's 0.01. That sheet, the formula sheet here, snip this in, is going to be your friend here. This is what you're looking for. So your confidence level is, well, actually, so we could have gone right to the table, and I apologize for maybe making this more confusing. Right there, we can go right there. That's the Z value you want, 2.33. So your margin of error is just the part to the right of the plus or minus. 2.33 times the standard deviation, 269.52, divided by the square root of 39.
Okay.
So everything up here is true. It's just, it was extra work, which did, we don't need to do all that.
So did you get 100.56?
Yes.
Okay, perfect. I see it.
All right, let's go to the next question here. Let's see. Maybe it's that one.
6. It should be.
Okay, they started coming in out of order, so I'm gonna go find it.
Sorry.
That's okay. Come on, 17, 18.
Oh shoot! 1, 2, 3, 4, 5.
So we can just do them out of order if this one isn't right.
Okay.
15, 16. Is it okay if I just?
No, that's yeah. Here, I'm sending more over. Sorry, of course. I don't know if that's better now. Do you see them?
Yeah, so you just send another one over here. So I got 4 and 5 again. There's another one. There it is. All right, thank you. All right, number 6.
I think probably sent all of them now. Oh.
No problem. It's not like texting someone over and over again. Email's a little more kind. All right, determine the sample size needed to construct a 95% confidence interval to estimate the population proportion is 0.38 and the margin of error is 0.037. We kind of did this earlier, but we didn't do it for a proportion. So let me grab the formula for that. It's kind of down most of the way down on your page is the calculating sample size, but it's for a proportion. So it looks maybe more complicated than it actually is. You need that Z alpha over 2, which comes from the 95%, which comes from the same table we used in the previous problem. So I will spare doing the wrong calculation. You go right there to 95%, and you grab that Z value.
And so 1.96.
Yes. So that's the first part.
Yeah.
You're given P bar. This is P bar in the problem.
Okay. How did you know
then,
those people? Oh,
so it's a good question. It's a fair question. Like it's the only proportion given. If sometimes they don't give you it, you have to calculate it. They'll say like 41 out of 109, but you know.
And
the
what
other
your numbers? Yeah.
That's the other one. So it's and again, you're rounding up, and it even says that to round up, but just keep that in mind. So 1.96 squared, 0.38, 1 minus 0.38 all over 0.07 squared like that.
Okay.
There's no like way to know if your answer is reasonable, other than you have to get a positive number, should be bigger than 1, but don't maybe just do the calculation twice on the test if you're not sure if it's reasonable or not. Fortunately, there's just not a guide for this. All right, so I get 184.71, so round it up.
That's what I got.
185.
Okay.
Question 7.
The whole test is multiple choice too. So
Oh, that's good. Now, on a problem like this one, your teacher will give you both 184 and 185 to choose from.
Okay.
So be very sure you know how to do that.
Yeah.
All right, it's kind of similar here. It says C is 0.99, proportion P bar is 0.69, margin of error is 0.06. So really similar. You go to that table again and get your Z for
Okay.
it ends up being 2.575. So it's 2.575 squared times 0.69, 1 minus 0.69 over 0.056 squared.
Okay. Okay. Okay, perfect. That's what I got.
All right. So I'm just looking here for question 8. You go to a new email. There it is.
Okay. Yes.
All right. Okay, spark plug manufacturer claims the lives of its plugs normally distribute with a mean of 60,000 miles. So that's sorry, we don't know that yet. Standard deviation of 5,500 miles. A random sample of 50 plugs had an average life of 58,000. Manufacturer's claim is correct. Was the probability of finding a sample of 58,000 or less? It does say to use a Z-score. That's important here because you may not know whether it's a Z or T based on some of this other information. See how it says the manufacturer claims, like that's kind of an indicator that this is sigma because it's like the known accepted value, but the Z further confirms that it's a sigma. So your Z here is X bar minus mu over sigma divided by the square root of N. So the how am I going to do this here? The X bar is from the claim.
Okay.
Because you're trying to find the probability that X is less than 58,000. So that's your X bar. And that's from 58,000 minus 60,000 over 5,500 divided by the square root of 50. So it says to round your Z-score to 2 decimal places. Like you have to follow these instructions, even though you could do it in a way where you don't do that. That's what they want. And then we can use the table to get that result here. So 58,000.
Negative 2.57.
Yes. So again,
Okay.
what that means is over here at minus 2.57, because we want less than, that's the left tail.
Okay.
Do you have a Z table you can send over real quick or?
Yes. Let me find it. Okay. And then how do you know if you're using Z or T?
This one tells you Z, and there's this whole discussion of like, well, are they giving you sigma? That's the differentiator. So they're telling you it's Z, so that's good. Like they're not trying to be unclear there. But if it didn't say that and it just said that the sample standard deviation was 5,500, that's a T. So your division between Z and T comes down to, do you know sigma? Is it known, or are you doing sample standard deviation?
Okay.
Do you remember from the previous exams if the questions, excuse me, were similar? Meaning, like, what do you think it'll tell you this?
Yeah, they look exactly like this.
Perfect. Okay, so here's a snip of the Z table for us to answer this problem here. So on the left here, you're looking for minus 2.5 because you're minus 2.57. That's horribly drawn. 57. And then you go to the top. You go to the top here and you look for that next decimal place. So in your problem, that corresponds to minus 2.57 there. So first go to the row, then go to the column. So your answer is 0.0.
Okay, so 0.005.
Yeah. All right. So that was that. All right, number 9.
So the answer is 0.0051.
Yes, and it's a little bit unclear, but it says to round the Z-score, which makes you might think that it is that, but it says and report probability, because it does ask what is the probability. The probability is the area under the curve,
Okay.
but you have to get the Z-score to find the probability, which is why maybe it's unclear. You have to do, one leads to the next.
Okay.
Okay. Okay. Average score in exam 1 is 150 points out of 200. That's the X bar. That's your, no, sorry. No. That's not okay. That's not okay. With a 30.8 standard deviation. So we're not saying it's known. We're just saying like there's a standard deviation. You went out and sampled some data and you found a standard deviation. So that's S. That immediately tells you that we're looking for a T.
Okay.
It's also the case that typically for T's, you end up rounding to more decimal places for your like T score. All right, she randomly selects 36 students, that's N, and they want to know the probability that a student will score 145 or more. So X greater than 145. So your T is X minus mu over sigma S divided by the square root of N. So in this case, it's 145 minus 150. So I was about to say that 150 was X bar. It's actually mu. It's like the one that we think is a good estimate of the population. Your S is 30.8 divided by the square root of 36. So we need this T value.
Okay. So 115.78.
I got a different number. I got that's pretty large. Like the T's are going to be between like -3 and 3 typically. Maybe a parentheses issue.
I don't think I didn't have parentheses. Maybe let me see. Yeah, because I didn't get it again. So I don't know.
So parentheses 145 minus 150 close parentheses slash parentheses 30.8 slash square root. And then if your calculator adds a parentheses there, you're going to want to have another one to close the 36 and then close the denominator.
Okay, got it. Perfect.
Okay, so this is only the first part. This is calculating the T. We want the area in the tail. Okay, now to use your T table, you have to get the right degrees of freedom. So your degrees of freedom in this problem is n minus 1, 36 minus 1 is 35. That's important because you're going to use the row with 35 in it in your table. So I'm going to go grab that. That's page 2.
Okay.
And this is where you might have a small issue on your exam. So we're looking at the row 35 and you're trying to figure out which two values is your T between. So your T is minus 0.9 974. Is that really right? Yeah, it is.
Okay. Oh.
So
So it's okay.
this is bad. I mean, this is where you may have to go to your calculator to do this.
Okay.
Because notice like you don't have any negatives in here because it's all in the upper tail. You can sort of like say, well, it's pretty close to that one, but that's not close enough for a multiple choice exam. So I can really quickly show you how to do it in the calculator.
Okay.
Is that okay?
Yeah.
All right. Let me go over to the calculator here. Let me know when that loads up there. Okay. So what we're doing here in this problem, it's under. So there's a couple ways to do it. First way is to go to stat tests, and we're doing a t-test here. Does that look like something you've seen before?
No. Wait, how'd you do? You push second and then math?
Sorry, stat. You're under stat. Let me quit out of this. Stat, and then test.
I don't have a test. I think my test is under math. Interesting. I have an 84. I don't know.
It should be really similar. So you're hitting the stat button here, and there's no tests.
Yeah, there's just names, ops, and math.
Yeah, you're hitting second. You don't know
Oh,
second. Just the literal stat button.
Okay. There we go.
All right, so this is a t-test.
Okay.
And you go to stats, not data.
Okay.
Your mu naught is the value of 145. So I'm just trying to get where I can see this again. 145.
Okay.
My screen is not working. There it is. Your X bar, I'm sorry, your mu naught is 150.
Okay.
Sorry about that.
No.
Your X bar 145. Okay. Your S is 30.8. Your N is 36. And then you want the area in the right tail because we want to know that it's greater than 145.
Okay. Okay.
This doesn't look right. I'm going to just draw this real quick. I don't know why this isn't looking right. You want to go to calculate if you can. Okay, it is right.
Yeah, I have that same exact thing.
Okay.
Negative 0.974, so then 0.831.
That gives you the area. Yeah. So that's what I mentioned. Like the table kind of shows you.
The answer?
That's the answer.
Well, can't I just do that on the test?
Yes. You can use the calculator for all these questions. But you have to know which test to use and a few other things. But
if I just knew it was t-table, then I could go to my calculator, just say t, and put all this in.
Yes.
I think that might just be easier.
Yes. And same thing for this one. You can go do a z-test for number 8. So again, just how we got there was stat,
test,
and then you have your options for z-test and t-test.
Okay. Yeah. I'll just do that. So much easier.
All right. I'm going to try see if we can get one more in here. I guess 10. We're up to 10. Yeah, we're up to 10.
Yeah. Wait, so what would the answer be? 0.8316?
Yes. Okay. Or because 0.832.
Okay.
Okay, according to the IRS, 79% of all tax returns lead to a refund. Random sample of 100 tax returns was taken. What is the upper limit on the sample proportion such that 50% of the returns exceed this value? Okay, so this one's pretty involved here. Sorry, no, it's not. What is the upper limit of the sample proportion such that 50% of the time would exceed this value?
Okay.
The way I'm reading this is that they're I'm actually not sure now. 75% all returns, random sample 100 taken. So I believe it's just asking for the what is the upper limit of the sample portion? It's just asking for the proportion in this problem. I don't know why it's asking for Z, because normally your normal curve here, 50% is above and 50% is below. So the proportion that's right in the middle there, in this case is the 0.75.
Oh, so that's the answer.
I believe. Now I don't quite like this because it's saying to round Z and they're talking about this, but it's I'm not sure. We'd have to spend a little more time on that.
Okay.
All right, we do unfortunately have to stop here. I know probably didn't get through everything you wanted to do. Do you have any other lessons scheduled?
No,
Okay.
I don't.
I do have some time